here at Tech, I run a lab called the Dynamic and Smart Systems Lab. That's where we are now in the lab. So my background is actually in smart materials. And these are materials that couple multiple physical domains. So a common one that a lot of people know about is solar panels. You get light energy coming in, you get electrical energy coming out. But there are others, and the one that I work with the most is called piezoelectric materials. Here you put mechanical energy in. You stress them, you compress them or pull, apply a force, twist, and you'll get electrical energy coming out. So what we're doing is integrating these materials into the components of knee replacements and using them for multifunctional capability. They can sense forces. So that's one of the things we're doing is we're sensing the forces in the knee after, this would be used after a patient gets a knee replacement, and we can use this to track the health of the knee. We can understand, is the knee balanced? Is the patient healing well? Because the loads that are inside the knee are very indicative of what's going on. And currently there is no sensing system that can be left in the knee after surgery. So that's where our research is driving, is to try to investigate sensing systems that could be integrated into the knee replacement itself so that after surgery, you get a sensor permanently as part of your implant. It can record this load data, among others, and transmit it wirelessly back to your health team. Now everything is connected, and telehealth is a big deal. So you can envision if I have this sensor in my knee, and just walking through my house, it can collect data. When I go to bed at night, it can transmit wirelessly to a computer or even a tablet or my phone sitting on my bedside table, and that can get connected back to the hospital, back to the surgical team or the nurses, and they can look at the data and see if anything's going wrong or make sure everything's going right. So within this lab, we have the ability to 3D print components for these knee implants, so we can do some prototyping. Of course, these wouldn't be the final components that would go into a knee, but we can do some prototyping here. So we're interested in integrating the piezoelectric materials into the polyethylene or plastic bearing that is inside a knee replacement.
So currently I'm working on the development of 3D printed capacitive sensors, and these sensors are to be used inside of insoles for pressure sensing applications, and this is to analyze gait and things like that for patients. And specifically why we're interested in the 3D printing development of these sensors is because people with any kind of foot deformities have trouble using regular insoles that are typical for pressure sensing applications. And these insoles aren't very customizable typically. You can only adjust maybe size or something like that. But using 3D printing, you can print the customized insoles according to a person's 3D scan of their foot, and then make it customized to their foot, and then you can use these sensors to sense their gait and things like that.
Another functionality of these piezoelectric materials is energy harvesting. And this is where every time you apply a load to the material, it generates a little bit of electricity. We can use that to sense, but we can also capture that electricity, store it in a battery or a capacitor, and power the sensor itself so that we don't have to install batteries in these devices. And that's a big deal if you're talking about a sensor that's going to go inside the human body. Things like pacemakers have batteries, but the battery life is maybe 10 years. So it's got to be replaced. It can't stay in the body longer than that. We want a system that doesn't ever need to be replaced. It can live as long as the knee implant is inside the body. So it's important to find a power source. And then the third area, that functionality of these materials that we're using, is called structural health monitoring. And this is where we purposely apply a voltage to the transducer, this piece of piezoelectric material, and it vibrates. Those vibrations get transmitted into the surrounding components of the knee, and then they reflect and come back to the same piece of piezoelectric material, and we can sense what's going on. So we can use them to try to sense loosening or wear in the components, and that's a big part of our research now where we're moving forward, is to try to see, can we use these materials to detect when an implant has failed? Not just the loads, but can we actively interrogate it with this sensing system? So it's truly a multifunctional system.
So what I've been doing, the vibrational data that he talked about before, what I have been doing is trying to determine what kind of machine learning algorithms best fit and best classify that data, determining whether or not the knee data is healthy or if it's damaged, and if it's damaged, what kind of damage is it, how severe is it, and most of that. So it's been developing those algorithms, figuring out which ones work the best, and kind of fine-tuning the parameters to try and get maximum performance out of them.
So we have a lot of opportunities for students, which is again one of the reasons why I love working at Tennessee Tech. So we have a thriving graduate program at both the PhD and the master's level, and students after they finish their bachelor's degrees, if they're interested in getting an advanced degree, we have all those options here at Tech. So I'm always working with graduate students at master's and PhD levels on this research, and those students do what I would call a deep dive. They're the ones that really spend years working on this and drive that project forward. So they're going to be doing experimentation, modeling, analysis, all of that, and writing up their results and publishing papers and those types of things. But we also have really great opportunities for undergrads. We have several programs at Tennessee Tech, formal programs as well as informal programs for students to get, undergrad students to get into the lab and get working.
There was a presentation that one of my teachers did in 6th grade. She brought her brother, who was a student at Tennessee Tech at the time, and he had this little, it was a hydroelectric car model that he, zoomed around the room and whatnot. And I thought that was the most fascinating thing. And when she told me he was from Tech, I was like, all right, that's what I want to do. That's where I want to go.